Good morning, good afternoon, and good evening. Welcome back to Chapter 21. We're talking about the digestive system. We're following the path of the food as it goes from our mouth ultimately to our butt. We've made it as far as the stomach. Remember, we're doing this process called digestion. The first step is to eat the food. The next step is to digest the food. So eating the food, ingestion, is part of the process of mechanical digestion. Digestion, remember, is broken up into two stages, mechanical and chemical. They both have the same goal. And the goal of mechanical and chemical digestion is to take something big and make it smaller. Mechanical digestion is taking big pieces of food and making them smaller. The goal of chemical digestion is taking big molecules of food and make them smaller. We're up to the secretion stage. We're up to releasing fluids into our food. We talked about the secretions of the mouth. We talked about the secretions of the stomach. We talked about the secretions of the pancreas. Now let's talk about the secretions of the liver. And the primary secretion of the liver is bile. Bile is a product that emulsifies fats. Now let me give you a quick definition of emulsification. But emulsifying means taking a big drop and turning it into smaller drops. I'll make that clear in just a minute, but that's the quick definition for what emulsify means, taking something big and making it smaller. And that's what all what digestion has been about, having it taking something big and making it smaller. Oh, the reason why we want to take big things and make them smaller is so that we can get more surface area. The smaller you make something, the more surface area you have. If I have more surface area, it means I can get more digestive enzymes around the perimeter, which allows me to digest the food faster. So the job of emulsifying a fat is to take a big droplet of fat and turn it into much smaller droplets of fat, so I can get more digestive enzymes around that liquid fat, and so I can digest it easier and faster. So that's what emulsification is. That's what bile does, is emulsification. As we said, chemical digestion is all about taking big molecules and making them smaller. It occurs in lots of organs, but the primary organ that does chemical digestion is the duodenum, really. It's that first foot of the small intestine. But it's actually done, chemical digestion takes place in the mouth, in the stomach, in the duodenum, and then organs that participate in chemical digestion would include the pancreas and the bile, even though, remember, the food does not go through those organs. It goes from the mouth, the esophagus, the stomach, small intestine, large intestine, anus, out. All right? So that's the alimentary canal, it's called. That's the stuff the food physically touches. The food does not go through your liver. The food does not go through your pancreas. Here we see how we break the different food molecules into their bits and pieces. Remember that proteins are just chains of amino acids. So these proteases will break down the proteins into their component parts, the amino acids. Amylases break down carbohydrates. So we have this big polysaccharide. Poly means many, saccharide means sugar ring. And these amylases are going to break down this long-chain carbohydrate into small-chain carbohydrates. And this is what we said. If you put the piece of popcorn in your mouth and you let it dissolve basically in your mouth, that salivary amylase will take this long chain of a polysaccharide and cut it into short chains, which is why it'll start to taste sweet. Nucleases, as the name implies, if a protease breaks down a protein, what do nucleases break down? Nucleases break down nucleotides. They break down DNA and RNA into their nucleotides, down into their separate pieces, the A's and T's and G's and C's. Last are lipases. Remember lipids, lipases. Lipases are enzymes that break down lipids. Proteases are enzymes that break down proteins. Nucleases are enzymes that break down nucleic acids. It's not, it is science, but it's not necessarily like rocket science. This right here is a triglyceride. The job of the lipase is going to cut this triglyceride up into bits and pieces And actually, it'll cut it up even more than this. This isn't showing how much it cuts it up. It'll cut it up even more than that, even smaller bits and pieces. The whole goal, the whole purpose of taking these big molecules and cutting them into much smaller molecules is so that I can absorb them across the lining of my intestines, so that the cells that make up the walls of my intestines can absorb these molecules. They can't absorb these huge molecules. They're too big to go through the cell membrane. Remember, let's go back to biology 1. The cell membrane can only let small things through. So we have to cut these huge molecules into smaller molecules so they can go from that alimentary canal, from that tube, into the cells that make up the walls of my digestive system, into the blood that's flowing through my digestive system, so that blood can carry those food molecules to the rest of my body. That is absorption. Absorbing these food molecules so that it can be transported throughout my body so that I can use it for fuel, so that I can burn it up to power my body. It's the gasoline that keeps your engine running. After I have absorbed all of the good stuff out of the chyme, remember, the fluid that travels through your digestive system is called chyme. When it's in the stomach, it's specifically called acidic chyme. One of the things that was in that pancreatic juice that I said is sodium bicarbonate. The first thing that happens to that acidic chyme is as soon as it comes out of the stomach and into that very first section of the small intestine, that pancreatic juice is going to neutralize the acid. And so it stops being acidic chyme, and now it's just chyme. That is the proof that you need to let you know that stomach acid's job is not to digest my food. It is to sterilize it, because the bulk of chemical digestion takes place in that duodenum. And we have just neutralized the acid. That's the first thing that happens. You neutralize the acid, and then you can break down those complex molecules. So I absorb those food molecules in my bloodstream. There's always going to be stuff left behind. There's always going to be stuff that I can't use. And that stuff that gets left behind is going to get eliminated. It's going to get expelled out of the end of the gut, which is a nice way of saying pooping. The last section of your intestine is called your large intestine. It is the organ that begins the process of elimination. The large intestine's job receives chyme from the small intestine, but what it's receiving is really no longer food. All of the stuff your body could use has been absorbed, and so what's left behind is literally the scraps. What's left behind is literally the waste, the stuff that your body could not break down, the stuff that your body could not use. And so the large intestine's job is going to take what's about to be feces and store it until you're ready to poop it out. It's going to compact it, make it tighter. But its main job, the main thing it's going to do to that chyme, and the difference between chyme and feces, is that it's going to reclaim the water. All of that secretion that we did, all that secretion that we talked about, we add like a gallon of fluid to the meals that we eat in a day. A gallon. And if we didn't reclaim that fluid, we would have to drink a gallon of water in addition to what we already drink. To replace all of that fluid we would be losing out of the end of our gut. Let me be gross for a minute. We've all had diarrhea. You've all had those poops where it wasn't solid at all. It was just liquid. And the reason why it was just liquid was because the large intestine wasn't doing its job. Something happened. You got some sort of a bug in the food that you ate, some sort of a microorganism, some sort of a pathogen in the food that was able to survive your stomach acid, and it made it from your stomach into your intestines. And when it got to your intestines, your body said, hey, wait a minute, there's a bacteria in here that's not supposed to be here. This thing is bad. We need to get rid of it. Well, because it's already gone too far, you can't throw it back up again. So it's got to go the other way. And going the other way means it gets pushed through the large intestine without stopping to have that water reclaimed. That's why you have liquidy diarrhea. Your body's trying to save itself from whatever this invader is that's not supposed to be there. Again, allow me to be gross for a minute. Imagine if we didn't reclaim that water. You all held a gallon of milk. I want you to imagine taking a gallon of milk to the toilet and just pouring the whole gallon into the toilet. And how long would that take? Well, that's what pooping would be like if the large intestine didn't do its job, which is to reclaim water, to pull excess water, not excess water, but to pull the water, the fluid out of the foods that we've taken in. That is its primary job, reclaiming water.